You know when you look up at a really dark night sky, you see those little, faint, fuzzy patches of light? Just kind of hanging out between the stars? Well, for most of human history, nobody had a clue what they were. They were a total mystery. So today, we're going to unravel that mystery piece by piece. All right, so here's our game plan. We're going to start with a huge scientific showdown, then get into the one discovery that literally changed everything. After that, we'll take a tour of the galactic zoo, and finally, we'll zoom way, way out to see our place in this grand structure called the cosmic web. So let's kick things off at a time not even that long ago, when we weren't even sure if our own galaxy, the Milky Way, was the entire universe. I mean, can you imagine? For centuries, our whole view of the cosmos was, well, tiny. We went from thinking the universe just stopped at Saturn's orbit to suddenly grappling with this wild new idea. What if those fuzzy patches in the sky were entire universes of their own? The first person to really go there was the philosopher Immanuel Kant. Get this, way back in 1755, he had this incredible thought. He suggested that these nebula weren't just clouds of gas, but distant island universes, or as he put it, other Milky Ways. So, Kant's idea? It was pretty radical, and it didn't really catch on for a long time. In fact, by 1920, it had sparked what's now famously called the Great Debate. You had two heavyweights in astronomy going head-to-head. On one side, Harlow Shapley, who sang, "Nope, these spiral nebulae are just gas clouds inside our own Milky Way. Our galaxy is it, the whole shebang." But on the other side, Heber Curtis is arguing, "No way! These are distant, separate galaxies. The universe is packed with them." The whole debate was basically a stalemate. Science needed more evidence, more data, and it turns out one astronomer using a very special kind of star was about to blow the whole thing wide open. And this was the key: a Cepheid variable star. The easiest way to think of it is like a cosmic lighthouse. Its true brightness is directly linked to how fast it pulses. So astronomers could compare how bright it actually is to how bright it looks from Earth, and boom, they could calculate its distance with amazing accuracy. It's like a cosmic yardstick. So in 1923, this guy, Edwin Hubble, points the massive Mount Wilson telescope at the Andromeda Nebula, and he finds one. He spots one of these cosmic lighthouses blinking away inside it. All of a sudden, he had the exact tool he needed to settle the debate for good. And the number he came up with was just staggering. Hubble calculated that Andromeda was 2 million light-years away. To put that in perspective, our own Milky Way is only about 100,000 light-years across. This wasn't in our backyard, it wasn't even in the same city. And just like that, with that single measurement, the argument was over. Heber Curtis had been right all along. The nebulae were other galaxies. Our universe wasn't just the Milky Way. It was filled with billions of them. I mean, just try to wrap your head around this. In a single instant, with one observation, the known universe got about 700,000 times bigger. Poof, just like that. We're talking about one of the greatest, most sudden paradigm shifts in the entire history of human thought. Okay, so now astronomers knew these galaxies existed. The next obvious step was to start classifying them. And what they found was this stunning cosmic zoo, just full of all these different shapes, sizes, and structures. Today, most galaxies get sorted into 4 main families. You've got the smooth, kind of blob-like ellipticals, the really elegant spirals, their cousins, the barred spirals, and then the ones that just don't play by the rules, the chaotic irregulars. So for the ellipticals, it's pretty simple. They're basically graded on how stretched out they look. They go from E0, which is almost a perfect circle, all the way to a very flat, elongated E7. Spirals get broken down even further. For example, an S-type galaxy has this really big, bright center, and its arms are wound up super tight. But an SC-type has a small little core and these beautiful, open, really well-defined arms. And our own Milky Way? We're pretty sure it's a barred spiral. And then you have the irregulars. These are the real cosmic rebels. They have no defined shape at all, and they're often the result of just gravitational chaos when two galaxies collide. A couple of the most famous ones, the Magellanic Clouds, are actually visible from the southern hemisphere. So we've got all these individual galaxies, right? But here's the thing. They aren't just sprinkled randomly throughout space. If we zoom out even further,
we find they're all part of this breathtakingly huge, interconnected structure.
Our cosmic address starts right here in our neighborhood. We're part of what's called the local group, which is a collection of over 100 galaxies, including us and Andromeda, all held together by gravity. But that's just our little block. You zoom out from there, and our local group is just one tiny piece of the Virgo supercluster, a cosmic metropolis with more than 2,000 galaxies in it. And even that incredible structure is just a single branch of something way, way bigger. This is Laniakea. It's our home supercluster, and it contains a mind-boggling 100,000 galaxies. Now, when you map all these superclusters, this stunning pattern emerges. It looks like a giant cosmic web. You have these bright filaments made of countless galaxies, and they're woven around these immense, dark, and almost completely empty regions called voids. This is the grand design of our universe. It isn't uniform. It has a real structure. And this whole structure leaves us with this final, pretty profound question. See, because the universe is expanding, only the galaxies in our own local, gravitationally bound group will ever really stay together. Everything else, every other filament, every other supercluster in that cosmic web, is moving away from us. They're destined to eventually disappear beyond our cosmic horizon. So, what on earth does the future hold for this grand cosmic design?